Chris.
There was this question on the problem set.
Okay.
Number 35. And it said, how many is there?
Just tell me the gist of it, do you remember?
I think it was, it had
Quantity 3 plus radical 5 squared minus 3 quantity minus 6 quantity 3 plus radical 5 plus 4 equals 0.
that was an old one.
Was it?
No, it was like a whole,
Well, 4 is 9 is like quantity, which is quantity.
it was like you had to plug it in.
Oh, was this the substitution one?
Yeah, exactly.
Yeah, it was like was there one with X? I thought there were X's in the substitution.
Yeah, I think so. It was like, you had to, they gave you two different,
Yeah, that's the wrong one.
you
Equation.
can't substitute.
There was one with X's that you had to substitute. Like they gave you it was like 3 plus radical 5 and 3 minus radical 5.
Yeah.
And you had to, you had to
It-
plug it in for X.
Can you find it?
You just
Yeah.
have to, you just have to simplify it.
Oh, here it is.
You just
Okay.
improve that.
It was x squared minus 6x plus 4 equals 0. And you had 3 plus radical 5 was x, and 3 minus radical 5 was x.
So those were your solutions, right?
You just had to plug in
And you had to prove that that was true. Right? Okay. So for this kind of a problem, what you're asked to do here, and you're going to see that in the next, thank you, Kate, in the next chapter or the next few topics, we're going to learn how to solve this equation right here by using the quadratic formula, which many of you have probably seen before and you're probably used to it. And when you use the quadratic formula, you always get, remember the plus or minus? X equals negative b plus or minus the square root, that whole thing. This is where the plus or minus is coming in here. Okay, so what they want you to do with this problem is just plug these in to verify that they are the answers. So you're simply going to plug them in to see that it's true. So I'll do one of them, I'm not going to do both. So let's take a look. We got, so plugging that in the first spot, and the second spot, and then the rest. So again, what you're doing is you're taking the solution that they're asked to give you, that they give you here, plugging in for x here and here, in those two locations. Okay? Do you know how to do it from there, Chris?
Yeah.
Okay, I'm going to foil the first part, make sure. Okay, don't forget to foil. Other questions? Other ones? Anything in general, just in general for the test, the homework, whatever. Whatever you want to ask that's been maybe troubling you. Where's the other one you guys just had a minute ago?
That's the
Yeah, this is the one you want to grade right here, and that's the other one?
Oh, yeah. You
Just
can grade
grade
both, whichever one is higher grade.
No, just right at the top of this, to grade this, but put that behind it.
You can grade it.
So just write a little note here, grade this version.
do the same thing. You put both in.
But it says a little note at the top. Don't grade both.
It's okay, I'll just write.
Second? Yeah, the note up there is just to grade one. Jared, do you have a question specific? No? There's got to be some questions. I could sit here and we could just have open, textbook look at it. You have to ask something.
I mean, the only question I have, I know how to do this stuff, it's just when, I don't know what to use what. Like this certain problem, I don't know when to square both sides.
So you want to just do an example with one of those where we're solving?
Yeah, I just need.
Alright, so let's do one like this. How about this one? Okay, something like this?
Mm-hmm.
Alright. What do we think for the first step here? What can we do? Kate?
Add radical x minus 4 to the 1 side.
Yeah, move the x minus 4 over as adding. Okay? Now, once you've done that, you've isolated this radical over here, right? This radical is now isolated, so you can then square both sides. That's the key though, Pat. Again, you can't square a side until one is at least isolated. So remember here, up here at the top, it would be pointless to square this and try and square this whole side. It would be messy. It's once you isolate one of the radicals, it doesn't matter which one really. Okay? But once you do that, then you can square. And notice the right-hand side, you're going to have to FOIL. Right? The left-hand side is easy. Okay, that's just the x plus 1. Because those cancel. But the right-hand side, you need to FOIL. So we have 1 plus root x minus 4, 1 plus root x minus 4. You don't have to write this out, but sometimes it helps remind people they have to do it. Okay? So, first term will give you 1 times 1, which is everybody.
1.
Okay, middle term.
No, isn't it 2 radical x minus 4?
Yeah, because you're going to have root x minus 4 times 1 and root x minus 4 times 1. So there's going to be root x minus 4 plus another root x minus 4. So in the middle we can write it as 2 root x minus 4s. Yes, no? When I multiply outer, I get root x minus 4. And when I multiply inner, I get root x minus 4. So I would have root x minus 4 and then another root x minus 4. So together it's like having 2 of them. So instead we put a 2 out in front here. It's like saying this, Pat. Right? U plus U equals 2U. So this is like having this and this. That's what you would have. But instead, Jared's just putting the middle terms together right away.
Can you just square them separately? Then where you square just 1 by itself and then x minus 4?
What do you mean square them separately?
Like, because I don't know if it's just me, but like with the 1 plus x minus 4, then like that's kind of confusing.
You're multiplying. That's why you're supposed to multiply. 1 times x minus 4 is just x minus 4.
Yeah.
1 times root x minus 4 is still just root x minus 4. Okay? Then you're going to have to multiply the last terms. Root x minus 4 times root x minus 4. The roots cancel when you multiply them, remember. Because when you multiply two things that are the same, it's like saying squared, right? So these two here, multiplying these x minus 4s under the radicals, when they're multiplied by themselves, they become x minus 4 under a radical squared. But the radical and the squared cancel each other out. So now you have to combine the middle terms, though. You have to. Because you're going to need to get rid of this radical in a minute. Okay, so think of x minus 4 under the radical as u. This would be u plus u, which is 2u. But instead of a u, just write down the x minus 4 under the radical. Okay? So again, we're just combining like terms. So take these two and combine them.
Do you isolate that now?
Okay? Yeah, and that's the key here. These problems are tough because you isolated one of the radicals first and got rid of it, but that still creates another radical. So we need to isolate this radical now. Okay, the resulting. So to do that, let's move. Okay, let's move stuff over. You notice there's a 1 on both sides, right? Okay, subtract 1, subtract 1. There's an x, subtract x, subtract x. There's a negative 4. Add 4, add 4. See what I'm doing? Why am I doing this all? To get this by itself, okay? To get this by itself. Now, when you subtract the 1 here from this side, these 1s cancel right away, right? But you still have a plus 4. The x's cancel, don't they? Because x minus x drops off. 1 minus 1 drops off, leaving only a 4 over here. Then what can we do? Right, what can we do next? Divide by 2. Okay, divide by 2. Why? Because 2 is a coefficient. The thing is this. Think of this radical as a variable u in your mind. If this was 4 equals 2u, you would divide by 2, right? That's why I gave you guys that hint. Think of u. Always think of u in your head. Okay, that leaves behind 2 equals root x minus 4. Good, and then square both sides again. So you can see that in this process, we are squaring twice. We're squaring in the beginning, and then we're squaring at the end again. Be careful, gentlemen. It was plus 4, yes. Okay? Add 4 to both sides, you're going to get x equals 8. X equals 8. I see some, just thoughtful looks right now. People all right? So again, just to step through the process. Here's the beginning point right here. We have 2 radicals. We choose either radical to move over. It doesn't matter. So we chose this radical to move over here. Okay, after that, we squared both sides, leaving us with this here. And when we squared this term right up here, we think of it as FOIL, giving us these 4 terms here. The middle 2 terms combine to become this. We then have to combine like terms. We see there's x plus 1 here. There's a 1 here, subtract the 1. There's an x here, subtract the x. Those cancel. Add the 4 over also, giving us a result of 4 equals just the middle term we had there. Divide by 2 to put this 2 over here to give you a 2. Square both sides. Square this, this drops. 2 squared is 4. Add this 4 over to this side, giving you x equals 8. Okay? At the end, what should we do? Check. Check, 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 check. Say, Joe? Absolutely. This problem here is a 9-point problem tomorrow. I'm going to tell you now, if you don't check, you're going to lose 2 or 3 points. Okay? So if I were to check this myself, it would look like...
The original problem with it, and then works it out.
I would do this. You always show the original.
Also, we don't have to write, the original with or without the...
The original with the substitution is fine. So I would start with that, and then I would write this. Okay? Because again, 8 plus 1 is 9, and you know the square root of 9 is 3. 8 minus 4 is 4, and the square root of 4 is 2. So you can jump that stuff, that's fine. But just show this next part here. Okay, so what would your solution be? It would be 8, like this. Okay, remember to write your solution at the end. So you have the whole problem itself, you get an answer, you check your answer or answers, hint, check your answer or answers, and then one or both of those answers might be in your solution set. Or what happens if they're not? What's the solution set?
No solution,
Not solvable or no solution. And we can write it 3 ways. Ready?
The zero line, no soul.
Okay, no solution. 0 with a line through it, or the literal empty set. Okay? Any of those are acceptable. You should know all 3 though. You should know all 3 of those. Is there on the test multiple choice? Yes, there is, definitely. There is multiple choice.
Is there going to be a lot of questions and we have to work really quickly? Or
I don't think it's that long of a test. It's 4 pages.
Whoa, how many questions?
It's not necessarily my
The first 3 are all multiple choice and free and short answer. The last page is free response. So it's sort of 22 questions, I think. No.
You've given us words.
Oh, I'm towards it.
Yeah.
Yeah, there would be next round.
Can I see that?
The best thing you can honestly do, look over your homeworks, okay? I mean, you all did the problem set, so that should be good enough to help you study, but look over your homeworks, and then look at our examples you do in class. I pull a lot of the questions from the class examples. I don't know, what period is this tomorrow, guys?
Tomorrow,
Third? It's
wait, is it?
No, it's second. It's second. Third is activities tomorrow. It's first and second for sure.
Yeah, right.
Because day 4 is a weird day.
Yeah.
Me and her just gonna
Well,
go.
good.
Sorry.
All right.
Yes, we can study and go free.
Other questions?
Do you have goals before?
That's tragic.
Let's do another example.
It's one of those really long ones, like the 9 points. Whoa,
That was
do that.
So that you're running
Change
again
a lot.
now.
What is this?
Is this the
Oh, I figured this one out.
We did this? When did we do this?
No, we have-
It was in the problem set.
Well,
You said this is gonna be hard. Because I asked you about word problems and you said this.
You can expect to have this kind of a problem. Given a Pythagorean, or given a right triangle, use Pythagorean theorem to find the value of h.
Is that a 6? Root 6?
Yeah.
So words for like B.
6. It can only be one variable, right? So, what's the formula, Joe?
A squared plus B squared is...
You need to know that. Okay, I'm not going to provide you with that. Because that was in your homework and it was in your problem set. You need to know that. Yeah, you should know it.
There's never a third grade.
A plus square root of B.
We were done in third grade. We were like, huh? They just FOIL the stuff out and then you get your answer.
Good, now that's the key that Joe just mentioned. Please, so many students make mistakes in this part. You need to FOIL. You can't square the root 4 and square the root 6 by themselves. We prove that in class. If you want to see, you can feel free to look back in your notes. Okay? So, remember this is what you're doing. I'm not going to write it out. Okay, let's go ahead and write out what we get. You do root 4 times root 4. You're going to get 4. Root 4.
Mr. Howe,
Yes.
would it be better to simplify it in the beginning to 2 minus root 6?
Oh, I would never put root 4. You're absolutely right, Jared. Sorry, let's make this root 5. That makes no sense at all, because that would just be 2.
What?
Root 4 is just 2, isn't it?
Yeah.
So I would never leave it as root 4. It should be root 5 or something like that.
Oh,
We
great.
thought you were just gonna be
I just did the whole problem.
That stays. Yeah, sure you
I
do.
have to erase the whole thing now.
Thank you, Jared.
Usually at a free 5.
Okay. Next. Outer is root 5 times root 6, but with a negative sign.
And there's 2 of those, right?
Say again?
There's 2 of those. 'Cause if
And there's 2 of those.
They
Okay.
don't cancel? Wait, the square root sign does not cancel?
No. Only square root sign only cancels when they're the same inside. Like, because root 5 times root 5 gives you root 25, which reduces to 5. That's why the square root sign drops off, Joe. What's root 5 times root 5? Yeah, square root is 5. That's this part right here. But when you take the root 5 here times the negative root 6 here, right, this root 5 times this negative root 6 gives you negative root 30. But root 30 doesn't drop off. That's why it doesn't cancel. Okay? And then you do the inner, which is negative root 6 times root 5, giving you another one. Notice they're repeating themselves. And then root 6 times root 6.
6.
Yeah, and it's a positive because, yeah, both negatives. Very good there. Okay, next. Root 2 times root 2. You don't need the parentheses, but I'm putting them just to show. Root 2 times 3. Another root 2 times 3. And finally 3 times 3. Okay? Now, there's a big plus sign in the middle here. I'm only putting the parentheses to emphasize the fact that we're doing them separately. But now you can combine like terms and drop the parentheses. Everybody hear what I'm saying? Okay, you do not need the parentheses anymore. So add all your numerical values together. What do you got?
5.
What do you got, Kate?
22.
Good. You're going to get 11 and then 11. Okay, they're both going to be 11s. Break up root 30. Or let's combine root 30 first. Minus 2 root 30 plus 6 root 2. Alright, this becomes 6 root 2 here. This becomes a negative 2 root 30 because there's 2 of them. What can 30 be broken into? 2 and 15. But are those perfect squares? 3 and 10. Are those perfect squares? 6 and 5. So, it's one of those ones that you can't break down. So what does h become? Just take the square root.
What?
Oh.
Because you're solving for h, aren't you? So just put a big square root. But you can't. Just leave it like that.
Okay.
That's all you can do.
That's cool.
Okay? I'll tell you now. You could get a numerical, but you would just estimate it for now. But I'll tell you now that on the test tomorrow, the values are going to work out in a fashion so that you're not going to have like a complicated thing. You'll be able to take the square root of a number.
When I get that, I'm like certain I'm wrong.
Yeah.
No, that's absolutely right, because I just pick random numbers today. But tomorrow it'll work out, I'll tell you that.
So I was
Okay.
thinking that like you're trying to pull a trick on us and be like, ha, you did it all wrong. Because that's what
They're not tricks.
yeah, they're.
You're crazy.
Look at you. You don't know them well enough. What are you doing?
Nothing, you're just in my way.
Oh, no.
You're such a small class. I know, it's weird. We should space it out. We're like squished into a third of the room. Half of the room.
No. Joe goes over
Kate behind the door.
there.
Just relax,
Yeah,
relax.
what do you make better at? Tell you the thing. Kate under the desk. In the closet? Okay, why don't we take like a long walk out the window and see if we can stay there?
Focus, 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 focus. Let me make this a little tougher.
Yeah, doesn't count. I'm confused. I have so much stuff.
Alright, so a problem like this. This is a good example of where you might want to use the u value and use substitution. So you might say, let u equal the radical. Okay, so rewrite the equation. It becomes 2u plus u minus 3 equals 3. It's a lot easier to see, isn't it? Okay, so now you have 3u here. When I move this over, that equals 6. Now, does that make sense so far?
Yes.
Now, you know what u was defined as earlier, correct? So since u is 2, and u is also this, set 2 equal to this now, and solve for x. Okay, do you all see what I just did there?
Yes.
By the law of substitution, or the transitive property of equality. Good. Are we done? Without yawning? Check it. Very good.
That's your
Okay.
answer?
That is the answer.
That is, wait, can you do that for any type of problem with radicals?
Use substitution? Yeah. It works better. Now here's the thing though. Listen. If the radicand were not the same, you can't do it.
Ah, makes sense.
Again, see this x plus 1 is the same here? That's why it works well. If this was x plus 1 and this was x plus 2, you can't do it.
Is there a way to do it?
Since it's cube root, what if it was like one was just a square root?
Then you can't do it either. The radical must be the same, the index must be the same, the radicand must be the
You're
same.
gonna put one of these.
Okay?
You are.
Let's check. You are?
Honey.
I'm gonna use that.
We're allowed
You're going to use that? Really?
Get one.
We can do this all day. Can you use calculators tomorrow? Sure. Absolutely. But know that when a problem says simplify, and say the answer is like 3 radical 2 is your final answer, don't give me a decimal. I'm 100% sure. I don't want to see a decimal. Okay? Everything is going to be in terms of radicals. So don't say, oh, I have a calculator. Here's the decimal value. So,
Point of not giving the decimal because you want the exact answer.
Is that right?
exactly. That's exactly right.
You're still right now? It's not so, you're right all the time. I don't know what we do with that.
Please look up, guys. Come on, turn around.
I want you to know that food makes you look really tall.
Turn around. You get 4 plus 2 is 6. 6 minus 3 is 3. So 3 is equal to 3. So the solution set, be careful. People put the answer as 3. It's not. It's 7. It always happens, okay? Because you get 3 equals 3 and then suddenly, oh, that's 3, the answer. No. That's just a check. The answer was from up here and it's 7.
Why not you check?
Joe.
Simplify. Simplify.
Square root.
Jared,
Um,
it's not an equation.
wait, x over x cubed, radical x cubed over radical y squared. And then x, and then it's y over x radical x squared times radical x.
Slow down. Not y over, y is
I
under.
mean y over y.
Okay.
And then x radical x over y. That's what
Okay.
Yeah, just.
Again, start with the first line. You have a negative exponent, move it down to the bottom. Break up the radical to both parts. The square root of y squared is just y. The square root of x cubed needs to be broken into perfect square. Here's the perfect square. Bring it out front. This becomes x. This is left over.
If we wrote exact, like, if we took a ruler square and say it's square, I would get some credit for that. That's a positive.
I like a structure.
I blocked you.
You're the one that sends me Snapchats of your
I
stuff.
blocked you.
That's awkward.
I don't send you Snapchat.
Where is this conversation going?
Guys, focus. How about this one?
I got it.
Square.
I got it.
You see, don't square.
Raise your hands.
X.
Raise your hands.
Oh.
X.
Ryan, go ahead. Thank you for raising your hand.
Square root. Oh, you should insert a value. Right. Square root of quantity 3 squared or 9 times 4 times -2. And then square it. And you get 81. So square root of 81.
72?
Huh? 9 times
9 times.
72 the basic.
Oh, do the inside first, though.
9. What do you mean?
I would do the inside first.
Yeah, 72 times -2 is 144.
72 squared.
72 is the actual number when you multiply all three.
Oh, alright.
9 times 4 is 36. 36 times -2 is -72.
It's great. I don't know off the top of my
You're
head.
gonna get 72 as your
Yeah.
answer. Squared.
Isn't it?
They cancel out.
Yeah, they cancel out, so what's the answer?
72 positive negative.
Hey.
No.
No.
Positive.
Positive.
Hey, positive. In the middle.
Is it just like 72?
The answer is just 72, but what's the key here? It's not negative 72. Because what happens? When you square a negative, it becomes
Positive.
positive. And then when you take a square root, we only look at the principal root. Remember, this is not an equation, Joe. When you're solving an equation where it's like x squared equals 25, and you take the square root, it's plus or minus 5 for sure. Okay? But in this kind of a problem, when you're just simplifying, you square the 72, or the negative 72, giving you a positive large number, then taking that square, it gets back to 72. That's why your textbook, if you notice, has been doing this. Has anyone noticed in the back that this, they write like this? Has anyone picked up on that? That's the reason why.
Always me.
That's the reason why, though. Look, if you square x, say x was -3, and you square it, it becomes positive 9. And then when you take the square root of 9, you get back to 3. So they're telling you can't just put x there, because then it would say that this answer is negative, but it's the positive value, because it's the principal square root. Okay? Because when you square it, it gets the positive, and then take the square root, it still remains positive. What about the...
So close. So far.
So, 4x. 2x.
Why doesn't X just solve itself? Everyone has their own problems.
Thank you, Ryan.
In other words of five. I think what's this 5?
What do you got for this? This is from your problem set.
Subtract 8 over, and then divide by x.
Is that just
Nope.
2x plus 8 equals 2x, which doesn't make any sense?
Oh, jeez. Again, thank you, Jared. I don't know why I have the number 4. I have the number 4 in my head today. Like I can't get rid of the number 4.
I like it before.
I like that.
Sorry. So what's the process for this kind of a problem? You did this in your problem set.
I got it.
Last night.
Isolate the
But it's
negative.
the rule that you said.
Isolate the radical.
I don't see hands up. I see your hand, but you're talking, so I'm ignoring you now. Joe.
I don't know. So would you subtract the 8?
Okay, if you subtract the 8, though, watch what happens. You still have x on both sides, Joe.
Divide by x.
Can't divide by x.
Multiply by x.
If you divide, well, you could divide by x, but then you're going to have root 5 equals 2x minus 8 over x. You want to get x alone, don't you? But you have it in two spots. So this is not going to work. What should I do? Come on, people. You did your problem set, didn't you?
Yeah.
There were two of these in there.
Okay, so this, I remember doing this, but I'm not sure if this one's right. Would you square both sides first so then you could combine like terms?
Subtract
Oh,
x
oh.
root 5.
Divide by radical 5 on each side? Oh.
You did that?
I'm very disappointed.
We add radical 5.
That's what I just said.
Yeah, that's what it
Did
says.
actually say that.
I actually did
No,
say that.
Yo, why aren't you calling me anymore? I feel so left alone.
We've abandoned it as usual.
Okay? Move all your terms with x over and factor out the x.
Oh, see, like I can't see that in a problem.
Because you didn't do the problem set on that, obviously. Your partner might have done it then.
I did
That's
not.
what. So then how did you not do this? This was two of the problems, Joe.
Oh, I did it last night. I don't really remember.
Well, then you have to study a little more.
Problems that happen.
You have to study more. Now, at this point in time, what do you notice? Your denominator is irrational. So you have to rationalize it. So that's your answer, but you got to do this still. I'm telling you now, this will be a problem on your test. Okay?
If you don't rationalize it, you lose points.
Yeah, you'll lose a point for sure.
The point?
It depends on what it's worth. I don't like answering questions like that.
I did.
Okay? Numerator, just distribute, please.
16, 5, yeah, 5.
Denominator, it's binomial conjugate, so the middle terms cancel. So forget about the middle terms. Do first, giving you 4, and then last, giving you minus root 25, right? Again, we normally would FOIL. First, outer, inner, and then last. But the inner and the outer always cancel whenever it's binomial conjugates. So don't even do it. Just do the first and the last only when it's binomial conjugates. So the root 5 times root 5 gives you root 25, but it's a negative. So it's 4 minus 5.
I remember this one. We did this in class yesterday.
We did.
So x equals negative 16 plus 8 root 5.
Yes.
Oh man.
Most definitely.
And this is the kind of problem that I don't ask you to check. Okay, you're not going to be asked to check this.
I'm just checking everything. I'm not
Okay.
Then you have fun checking 8 radical 5.
I will check you at the class.
Mr. Howell?
Stop talking.
How did you get 16 minus 2 a radical 5?
It's about the belt.
Yes.
Because I wrote a typo, that's how. Thank you, Jared. Jared, you really watched me today. I appreciate it. Okay? Guys, tonight, study, please. Study a lot. All right? Do well on this test tomorrow. This is one of the easier tests for sure, but if you don't study, it's not going to prove that being true.